guys, you can see that over here. Let me zoom in. This is our if and else condition. If first button is pressed, first LED turns on. If the second button is pressed, second LED is turned on. Else, if both are not pressed, then both LEDs must be off. Now take a look here how it is implemented. I press the first button, first LED is on. Second button, second is on. I press both the buttons together like this. Both LEDs are on. See, so simple as that. Either you use the if else or if else and else. Both will do the same, but else if command will save a lot of time and also the programming space as well. Simple as that. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can use the if else and else if conditions in a PIC16F877A microcontroller using MikroC for PIC programming software. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And guys, these are the push buttons I'm going to use here for demonstration. And let me show you how to connect them. To connect a push button, you will need a 10 kilo ohm resistor each for each button like this. Then each button has two pins. One I name as LED1, other one I name as the VCC. What I'm going to do here is that I'm going to use the two push button and two LEDs to demonstrate to you how you use the if-else conditions in a PIC16F877A microcontroller. So let's connect them. You connect the VCC pin together of both the buttons and then you send it to the common VCC pin of the PIC. For the top button now, connect the LED1 pin to one end of the 10 kilo ohm resistor like this. From the same pin, take out your output. You can use any available digital input output pin. I'm going to use the pin number C0. And now from the other end of the 10 kilo ohm resistor for the top button, connect it to the any available connected to the ground pin of the PIC like this. Now for the bottom button, the LED2 pin connected to the one end of the 10 kilo ohm resistor like this. Now from the same pin, you can take out your output. I'm going to use the pin number C1. You can use any other available digital input output pin as well. Now from the other end of the 10 kilo ohm resistor for the lower button, connected to the ground like this. Now these are the two LEDs I'm going to use here. This is one LED. To connect this LED with the PIC, you will need a 220 ohm resistor. You can use higher value as well. Higher the value, lower the brightness will be. So, but this resistor is important. It's basically a safety resistor. It will save the LED from getting burned. Now to connect it, you know that each LED has two pins. One is longer, one is shorter. Shorter is always the ground. Connect the shorter pin to the ground. And for the longer pin, connect it to the one end of the 220 ohm resistor like this. From the other end of this 220 ohm resistor, you can connect it to any available digital input output pin. I'm going to use the pin number B5 like this. Now for the second LED like this, use the same way you have two pins, one longer, one shorter. Shorter is the ground, longer is the power pin. And then you will need another 220 ohm resistor for that. Connect the longer pin to the one end of the 220 ohm resistor like this. From the other end of the 220 ohm resistor, connect it to any available digital input output pin of the PIC. I'm going to use the pin number B6 like this. Now this is the hardware I'm going to use to demonstrate to you how you can use the if-else condition. We have left the top LED's ground pin. You connect it to the common ground like this. Now these are the two buttons. One button will turn on one LED and the other button will turn on the other LED. That's all. Then I will use if and else conditions, that if the button is pressed, then one LED turns on. If the other button is pressed, the other LED turns on. If both the buttons are pressed together, then both the LEDs must turn on. That's all. So let's get started. So guys, let me introduce you to the hardware. This is the hardware over here, simple as that. These are the two LEDs. I will be using only two LEDs and these are the two buttons over here we are going to use here, and this is our PIC16F877A microcontroller. That's all. So let's get to the MikroC for PIC programming. So guys, this is our MikroC for PIC over here. Let me zoom in so you guys can see better. So this is MikroC for PIC version 7.2.0. As you can see, I'm using version 7.2.0. You can use a higher version as well. Higher is always better. Click on new. Click on new and then click on new project like this. This window pops up, new project wizard. Click on next. Write the name of the project. If else condition tutorial by learning microcontrollers like this. Now guys, this is the path where your files will be created and this is the microcontroller. I'm going to use the PIC16F877A And this is the crystal you have at the pin number 13 and 14. I have a 20 megahertz crystal like this. Click on next and finish. So guys, let me save the work. Okay, the work is saved. So let's first of all initialize the button pins. So first of all we initialize the button pin at C0, tris C.F0 equals to 1. This command is like a pin mode input command in Arduino. So this is like pin mode C.F0. 1 means it's an input, 0 means it's an output, and button is always connected to an input pin. I accidentally created this, so let me remove it. Okay, let's save the work. Press Ctrl S to save your work. Okay, this is the button pin. Now the initial state port C.F0 equals to 0. Why 0? Why this button pin is 0? Because let me show you in the presentation over here. You can see that this 10 kilo ohm resistor is at the grounding end. Whenever the resistor is at the grounding end, remember whenever the button will be pressed, a 1 will be sent. So if the 1 is to be sent when the button is pressed, then initially your button pin must be 0. So that's why it is at 0. Now give some initialization delay. This is not necessary, but I always suggest you give it in the one-time loop like this. Now this is our first button for LED 1. Now for the LED 2 button, just change the parameters. It's at pin number C1, so it will be C.F1. That's all. Now we have our two buttons initialized. Let's initialize the LED pin, that is B5 and B6. So I write, just copy paste this again. This time is tris B.F5 equals to 0, because for the LED pin, your pin must be declared as output. So pin mode output is always used for LED in Arduino. So here it will be like tris B.F5 equals to 0. 0 means it's an output pin. Then this command is like a digital write, high or low. So in case of a button, your button, in case of an LED must be off by default. So by default, port B.F5 must be at 0. So it must be 0. 0 means it's low, 1 means it's high. Simple as that. Now for the second LED, just copy this, paste it here. B.F6 like this. Now this is B.F6. So initially this pin has been declared as output. 0 means it's an output, and initially the like digital write low, it's like port B.F6 equals to 0. LED is at 0. Now this is the initialization delay, not necessary, but in the newer versions of MikroC it's no issue. But in the previous version there used to be issue with the initialization, so we need to give these delays in those versions. But in the new version, I think you can go without it as well. But I always suggest you give it in the one-time loop. Now we go for our forever loop. Write down while 1. Forever loop starts here and here. And here you write, first of all, we will go if button is pressed, like port C.F0 double equals to 1. That's how you use the, this is the syntax of the if else. C equals to 1, because the grounding resistor, the resistor 10 kilo ohm resistor for the first button is at the grounding end. That's why whenever the button will be pressed, a 1 will be sent like this. If the button is pressed, a 1 is sent like this. But there is a problem as well with these buttons. These cheap buttons get pressed automatically because of various phenomena like dust particles in the air, etc. So for that you give this debouncing delay. Write down delay ms20 is enough. So if the button is pressed by some unknown phenomena like less than 20 milliseconds, it will not count it as pressed. So what we have done here is that we have used the if condition. If the button is pressed, like C.F0 double equals to 1, then it checks if still the button is pressed after 20 milliseconds, then it is counted as pressed. Now what we do is that we turn on the first LED, that is B.F5 like this. Now LED at B.F5 is turned on, and else if the button is not pressed, then what should happen? LED at B.F5 will go off like this. Like this. Now this is our if condition. Similarly we do for the other button as well. So just copy all of this. This is for the first LED. Now for the second button and second LED, C.F1, make it F1, because second button is at pin C1 and the second LED is at B6. That's all. Now we build this code and burn it, and let's see what happens. See that I had not used the else if conditions. Now you will see the difference why else if was important as well. So first we go with this only. So it's build, let's write it. Open the PIC3 programmer tool, click on file, import hex file. If else condition, this is a file, click on write. Okay, the new file is being written. Let's wait. Let me zoom out. Let's get to the hardware. See, the LED is blinking. That is because it is connected to the pin number B6. B6 is the PDM pin as well. It blinks whenever the program is being written. So I turn on the code. I get power from the PIC3. Okay, this is a good sign. No LED is on when the power is on. So now I press the one button. See, the LED turns on. That's fine. Now I press the second button. Second LED turns on. That's fine. So I am happy that our if else conditions are working. Now I press the first button, first LED is on. Second button, second LED is on. I press both the buttons together. See, both LEDs are on. See, with this button one LED, this button the other LED. That's all. Now we go for the else if condition. Let's see what the else if condition can do. So we are back to the code. Let me zoom in. So guys, now here we have if conditions, and you can see that we needed two else. One else here, one else here. Now this looks odd. If you have make a lot of loops, then this will be odd. So what we do, we will use the else if. So this will become a part of this. So we remove this else, like I copy this else and paste it here. Now it becomes else if, and I copy the condition inside it, and I merge it with this else like this over here, and I delete this else. Now what has happened over here? See, if this condition is met, then it will look for the other condition else if, and then else. Now similarly you can add various conditions here. This is called the polling method. So this is how else if can lower down the programming time. Also it will save you not only the time, it will also save you programming space as well. See that you need only one else for the two conditions. Similarly you can keep on adding conditions and you will only need one else. So that is the beauty of else if. Instead of using if else, you use if else, and then only one else for all the conditions. Now let's build this code and let's see what happens. Does it do the same? So it's build. I go to the PIC3 programmer tool, click on write. The file was already selected. So let's get to the hardware. This pin is the B6 pin, so that's why it is blinking, because it is the PDM pin and it has to do with the programming. So it's built. So see that it's a good sign. No LED is on by default because our else condition is working. Else both the LEDs must be off. I press the first button, first LED is on. I press the second button, second LED is on. I press both the buttons, see, same results. Both the LEDs are on. See that first LED is on, second is on, both are on. Simple as that. So if else and if else if and then else, they do exactly the same thing. But else if is more compact version of if else. If you have more conditions, then you go for the else if command. This will save you the programming space as well, programming time as well. So guys, this is it. If you have any questions, you can ask in the description of the video, or sorry, in the comment section. This MikroC for PIC code will be in the description. So thank you very much for your time guys, and have a nice day.